My name is Jutta Hildebrand, and I'm a LCA researcher at RISE IVF in Mölndal. And my former colleague Sandra Roos worked a lot in the Mistra Future Fashion project. So we have a lot of material that I'm going to show today, but from this occasion. But I have my own experience with textiles and life cycle assessment. That's what I did when I still worked in Germany with the textile finishing companies who wanted to use environmental aspects to reduce the costs that they have in textile finishing, and they found that making the processes more efficient and reducing the water demand and the energy demand for heating up was quite a good idea from their point of view. So they could see how this is beneficial for the environment and for their cost situation. So I'm going to start sharing my screen now, and you can probably let me know if that doesn't work. Share this one. And now we have the same that I think I need to switch to that. And now, no, can you see me? Yeah, now now it's in presentation mode. So
Yes.
so this is design for collection and recycling in the light of LCA was the suggested title, and I've switched that a bit. So the first part will be a bit more about LCA, what it is and how to do it. So in a nutshell, what it is about. And the second part is taking some highlights and results, also mostly from the Future Fashion project, to give you an idea how LCA can be used in textile design and also design in recycling. As one of the introductions, when you're interested into the background of this, I can recommend to check the results from the Future Fashion project. There you can download sample applications on sustainable fashion, and so the famous fiber Bible in 2 parts, and also the environmental assessment of the Swedish clothing consumption, garments, sustainable futures. And also some supply chain guidelines. I recommend that this is a good introduction also, and there's a lot of background and literature references also available there. But now, just jumping into the LCA background, and I think a lot of people have heard about LCA and have heard that it might be useful. The official name, sorry, when you see LCA, the abbreviation, the correct name, it would be life cycle assessment. But I think that in Sweden, because we say livscykelanalys, a lot of people say analysis, and we understand what you mean. It's fine, I think. And in general, the aim of an LCA is to assess the environmental impacts of a product from cradle to grave. So from the very start of the product, when you grow your cotton or take your oil that you're going to produce synthetic fibers from, that's where you start. And the grave is when it's put on landfill after incineration, obviously in Sweden. And this is your system, and this is what you want to assess. And what you do is that you find out what is necessary to produce or manufacture a product, and which emissions to air, water, soil, and which waste do occur along the life cycle. And that's your basis. That's the inventory that you're going to use for quantitative calculations. LCA has been used since the 1970s, so it's not a very new method. And among the early studies, and I think one of the studies that everybody says this was the very first, was packaging of Coca-Cola, packaging and distribution of Coca-Cola. Should they use glass bottles that they then have reusable glass bottles that then have to rinse and clean and transport back and forth, or is it better to use at that time, I think it was aluminium cans, and that's what they did in their study. to try what are the implications regarding resource use and mostly resource and energy use. There were not so many data on emissions back then. And this study was never published, so we don't really know how they did it, and it's probably not up to modern standards. That's what we can assume. And another initial use of LCAs is what are the hotspots along the life cycle, and how can a process or product be improved to reduce the environmental implications. That's an important part for the internal use of an LCA. You find out where are our environmental hotspots and what can we do about it? Where is it worthwhile to check further? Then, of course, you have the applications of an LCA, and so it's not only about finding out which material is preferable, has a lower environmental impact, but you also want to use this result in decision making. That can be an internal, when you decide about new producing or manufacturing processes, or about new designs. That's relevant for some of you, I've heard. But you also, and that's something that was also part of what Jonas spoke about. You want to use it in tools, and you want to use it also to claim, to support your claims in marketing. So you want to say that you do something about the environment and have what you have achieved with that. In general, there's a background on LCA. There's a definition in the ISO standard, and the ISO standard are two of them that are connected, 14040 and 14044. And they say that it's a technique for addressing the environmental aspects and potential environmental impacts throughout a product's life cycle by compiling inputs and outputs, evaluating the potential impact, and interpreting the results. So this is one part, a holistic, compile inputs and evaluate the results for different environmental impacts. And the other part, that's the key part, is that you have a life cycle perspective where you start with the raw material extraction and go all the way to the grave, the final disposals. Since there are so many different impacts on the environment, and a lot of people nowadays talk about climate impacts. That's one thing that's very well established and very well known. But of course, we're also interested in human health, and back in the 1980s, 90s, the most important topic was the state of the forests, which were heavily affected by acid rain. So it's not always the same environmental category that a lot of this is also mentioned on the slide. This is it's a holistic approach. So you use a lot of data collection is an important part, and you compile a lot of data on the process and on the product along the life cycle, and because you collect the data for different types of impacts, you can then in the end also assess whether a reduction of climate impact is on the other hand linked to an increase in another, for instance, resource depletion. That might be something that you're interested in. So it's a holistic thing. And one of the famous descriptions or illustrations of an LCA is from the ISO standard. And there you see that it has a goal and scope definition, which is usually the starting point. The data-heavy collection of data is the inventory analysis, but it's also impact assessment. That's important that inventory analysis and impact assessment are very well matched, because otherwise you don't get any results if you don't have data for one of the parts. That might be a bit disappointing when you start doing an LCA. And the accompanying part is always the interpretation. So it's doing it in the end, but interpretation is not just saying this is the result and we can see how much the the environmental impact can be decreased by a certain choice, but it's also understanding what are the implications of all the choices and the assumptions that you have taken along the life cycle or the analysis. So that's an important part. Now I need to find the so. And since we talk about the recycling and the collection for recycling, but recycling in general, this is very much related to the cradle to to the circular economy approach that is increasingly popular. And there you can see that we talk about a life cycle, and then we say it's from cradle to grave. And for a circular economy, the life cycles has some loops, and that's an important part of the circular economy, and that's something that an LCA has to address in a good way. So usually you start with the extraction of raw materials, the component production, manufacturing, use and maintenance, and disposal. So that's the cradle to grave life cycle, that the traditional life cycle from a linear economy. And all the approaches that are promoted through a circular economy do something about this life cycle and turn it into a loop. So it's now it becomes a cycle also due to this. Traditionally, you take the resources, use them, and discard them in the end. So take, make, use, and discard. But what you do with all different closing the loop activities, and that can be recovery, recycling, and reuse, is that you close the loop here. So instead of taking a waste material to landfill, you identify what can be made of it. Can we recover some of the materials through chemical recycling or through other means? And then instead of extracting natural resources, use this and basically cut off these two or reduce these two arrows: incineration, landfilling, and use of natural resources. So that's one step. And recovery is in the sort of hierarchy of closing the loop activities, often seen as the one that's the last resort, I could say, because it's better if you instead try to recycle materials and components on a higher level. So maybe you can instead of going here and processing the raw materials, you can already go to this part and use it for component production. It's more, I think that's more appropriate for other industries, but you can probably think of something that's also relevant for textile industry. And then we have this very nice shortcut that maybe the reason for throwing away or discarding a textile or another product is not that it doesn't work anymore. It's just that the user who owns it doesn't want it anymore. So this would be also one of the nice parts, that you can reuse a finished product, and then you don't need all these loops. You just go back from a finished product and turn it to another user, and that's obviously in the circular economy, that's often promoted as the highest level of closing the loop. When we want to come to the textile to make it more linked to what you do and what you are most familiar with, then there's also a circular life cycle for textiles. So we have on the left side, we have the biological materials, where we have farming of different types of products. There's cotton and viscose. And then it's going through a use or a production phase to the user. And so here it comes out again and can be used for energy recovery, but also for producing materials that are used. Or you can give it back to the biocircle, and it's turned into compost, and you use it again. So this is the green cycle is often the biological cycle. On the right side, you have the blue cycle, where you have all the finite resources that are made, in this case, mostly from oil, petroleum, and there you produce the components and go through the same production cycle. And this is where where it gets a bit complicated. Here are different loops, and here you can come to the reuse and all the chemical recycling and all these options. So mending the garments so you can increase the use phase, and shredding it to produce some components that can be used on a higher level, or going through a chemical recycling and then really going through all this cycle again. These are the options. And that's what you can do in a textile life cycle. Another description of this to to really get you hooked here is this, where you start with the raw material, have the fiber production, fabric production, wet treatment, finishing, garment manufacturing, retailing, use, and then end of life. And here are also several options to close the loop and to work with, and also to investigate from a life cycle assessment perspective. What are the implications of the raw materials? Do we have a raw material that comes with a large environmental footprint, with a large climate impact, or with a large water scarcity impact? Next is then, I will need to find the arrow. It's good that you don't see me, because now I'm searching. Next part that can be affected and is a heavy contribution to the environmental impact of textiles is the wet treatment, where you use a lot of chemicals and also use a lot of energy. And then we have the use phase, when it's washed and transported and yeah, mostly that. And here we have the recycling, reuse, and incineration, landfill in the worst case, the end of life activities, and that are the focuses of recycling and closing the loop circular options for textiles. If you know Sandra, then you also know that she's very interested in the chemical part of LCA, and this is something that is obviously very relevant and is sometimes a bit overshadowed when everybody focuses only on climate. So this is something that you have to have in mind, that of course you use a lot of raw materials along the life cycle, and in the raw materials, fertilizers, pesticides, and crude oil are used to a high extent. So the environmental impact might very well come from these raw materials. And that's an interesting part also from a life cycle perspective for recycling, because if you then manage, if you identify that the raw material production is the actual hotspot of the textile, then this recycling opportunities are very well suitable to reduce the environmental impact along the life cycle. And there are, of course, along the life cycle, other parts that can be relevant. So life cycle assessment in general is a cradle to grave perspective, but you can have subsystems. So you might want to check not the whole life cycle, but you are more interested in a cradle to gate. So you say, we would like to check what's happening until the factory gate, and what's happening upstream, and is there something we can do about with our suppliers? Or you have the gate to gate perspective, and then you try to dig down and find out what are the process steps that are necessary, and how are they connected. And again, from a life cycle perspective, it's then interesting to compile all the flows that go into this, and what are the auxiliaries, electric power, heat and fuels, what are water and process chemicals demand, and what comes out of that. So this is in principle always the part where you start the LCA. You have a model of the life cycle, and it's as always when modeling a real life situation, you have to make some simplifications, and you probably will not find all information on all the processes that are included here. But having an outline and starting with the life cycle model is the way to go. So trying to find out everything about the raw material acquisition, the processes, and the transportation that's linking all the different steps of the life cycles. And the important part from an LCA perspective is that you find out what are the resources used to make this life cycle happen, and what are the emissions connected to this life cycle, what's happening there. Still no questions? So yeah, that's, I said that just basically cradle to grave is the standard in LCA, and the reason for that is that you want to avoid some shifting between the life cycles. So between different parts of the life cycle. So if you for instance have a company that that produces from cradle to grave and make and report an LCA, and your competitors have made some decisions that they buy more materials that are prefabricated, and then they say this is not an impact of our own production. It's obviously not okay to compare those. So the by using the entire life cycle, this type of shifting between different parts of the life cycle can be avoided. But of course, sometimes it's interesting to look at parts of the life cycle in more in depth, and then you have to be aware what type of claims and what type of decisions can I make based on the fact that this is not the entire life cycle. So I had more here. Yes, so starting with the first initial step of the life cycle, the not yet data heavy part is that you define the goal and scope of this particular study, of this particular investigations that you want to do. And goal and scope definition in short includes that you think about the goal, and that includes the contextual aspects of the study or the investigation. What is the reason for the study? Which type of application do you have in mind? And that's an important part, defining a lot of aspects of the study. Who is the audience? Is this something that you want to use internally, or is that something that you want to communicate also externally? And what is actually the topic of the study, the investigation? Is it a product, a system, or it can also be something that's a service? That's entirely possible. So the LCA is flexible in that way. And then you nail it down a bit more and specify the questions. That's the goal. The scope has also to do with modeling aspects. And this is a central aspect in concept in life cycle assessment, that you define the functional unit. So what is the product or service that you are investigating actually good for? And it's not enough to say it's one T-shirt or one garment, but you have to understand also what is the life cycle of this and the use phase of this. How many times do I want to wear it? How many times should that last when it's worn by a regular user and washed afterwards? So the functional unit is something that needs attention. And then when you have decided on that, you also check the system boundaries. That means what has to be included in this life cycle assessment. And then you start drawing an initial flowchart. It's not so hard, so you can see that in the next slides. It's a starting point to really write what is included in the life cycle and then start collecting data. It's also good to understand from the start what are your data quality requirements. Do we need original data and specific data from the suppliers? Is that something that we are mostly interested in? What really happens in the supply chain that's connected to a production? Or is it okay and a good starting point to work with generic data from databases, even if we know that they are not perfect and that they may be not, it's not from our suppliers? And also the goal and scope definition has some procedural aspects. So which are the involved actors? So there should be the practitioner, the analysts, but also a commissioner, the one who wants this study and who also drives this study and is involved in decisions about how to do it. And then also the reporting, what should be come out of that? Is it an Excel file, or do we need a long report where we also have a very thorough interpretation stage? And this is also one of the concepts of LCA is that it includes a critical review, or it can include a critical review. You're not supposed to do it all the time, but since you have a lot of degrees of freedom in defining the LCA, what you're going to do about, and there are a lot of methodological choices, and therefore it's quite useful, especially if it's a study that you want to publish then in the end, and you want to have some claims that say that your product has less environmental impact compared to another one. Then it's really mandatory to have a critical review. That means you have another LCA practitioner, completely independent from your study, who checks what you're doing and checks whether your assumptions and all the choices that you have taken are acceptable from a methodological point of view. It's also good to have somebody who knows the area of technology. So once you're done with that, and that's one of the shorter parts of the goal and of the LCA, the goal and scope definition, you start doing the inventory procedure by constructing your flow model and starting the data collection. This can take time, and you hear it sometimes that people say this is the most time demanding part of an LCA, at least. Yeah, might very well be the case. And then you start the calculation of flows to and from the environment. And here the function unit comes into play. This is the reference to understand how the flows are connected and how to quantify the flows also. And this can be an example for initial flowchart. So you can start with as simple as this, that you say, yeah, we have the production of raw materials, that's clear. And the final product in this case, or the product that is investigated, is a detergent. So it's transported then to a chemical factory, then the formulation takes place, then it's distributed to the user, and once it's used it will end up in wastewater treatment. And then after the wastewater treatment, it will be released to a receiving water body. But the user needs obviously detergent and also some water. So this is a very simplified chart, and this is absolutely fine to start with something like that, and then identify what additional information do I need to come forward. So for the upstream and downstream process, it's relevant to include the bulk goods and commodities such as the electricity from grid, or the waste treatment in combustion plants and transport of goods. Here, we often work with LCA databases because it's not appropriate and it's not necessary to calculate the emission factors for Swedish electricity from grid all the time. So we take that obviously from databases, and it's easier to find such data sets that are commonly used by many people in a database. So electricity and transport you have a good chance, and also some generic data sets, so such as hydrochloric acid, that's very common, used in many different processes. So there you will probably find good data, or data in larger systems, for larger systems in databases. If you use something very special, and especially in textile industry, you use a lot of chemicals that are confidential, basically. So the chemical industry will not give you exact data on specific chemicals, such as the DBR treatment or DWR treatment, PFAS and all that type of special chemicals. Here it's quite the challenging part, and I think that's also the part that people refer to when they talk about the duration and how long it takes to get good data on these very special processes, and maybe they're not satisfied with what they get in the end anyway. But you do that. That's the I would say it's a lot of work, and it can take a lot of time, and you need to do this very systematically. But it's on the other hand, it's more a matter of being thorough and being clear about what you do and documenting it well, and that's what you can do in an LCA. So next stage, once you have still your initial flowchart on the side, but you have now found out which are it's not just one raw material, but now you know a bit more and understand that you need 8 raw materials that have to be mixed up in the formulation, and they come from different locations. So you have 8 different transports. Then it goes to the wholesaler, you have another transport, then it goes to the retail, then it have another transport, then it goes to the user. So this is now a more thorough, it's still not very elaborate, but this is absolutely fine to start with. And here comes one part that if you ever heard Sandra speaking, then you might remember that this is actually something that she I know it's Sandra, is very clear about, and I think it's good to show it in this very good example. The inventory analysis that you have done until now and the impact assessment, they need to be really good matched to come to results. And one of the things that can happen is that you have an LCI result and you have the matching characterization factor, so you will get a result. And that's basically the only case where you can get a result, if you really have it matching. When you have an LCI result, so you collect data and find out this and that type of emission is linked here or happens here, but you don't have a characterization factor, then the result will be 0. And on the other hand, also, if you have decided in the beginning that you want to use a specific type of impact assessment, but have no LCI results that support this impact category, then it's also 0. So you have to collect carbon dioxide emissions and have to include carbon dioxide as a characterization factor to come forward to an LCIA result. When you don't have any input, then it won't help. That's that one, and we don't have a characterization factor. So have not chosen this as a relevant impact category, then there's no result. And this is a bit more elaborate, a bit more complicated, of course, also when you look into other impact categories such as toxicity. You can only get forward to a result if you have both parts, the inventory analysis and the impact assessment, and they are matching well. So the thing that you have done so far is that you have collected inventory data, and the data that are most relevant and that are relevant for the LCA are those that cross the system boundary that you have defined. So inside is the flow chart, and it's a bit more complicated now, and everything that goes into the system as a natural resource. So that's taken from nature, from the biosphere, and goes into here. And everything that comes out of here as an emission or waste, that is what counts in an LCA. And so if you have a process that releases a lot of acids in the water, but you still have a wastewater treatment after that. So it's not going directly to nature, it's going to a technical process that takes care of this. Then this is a box that has to be included here, and only what comes out from the wastewater treatment plant and still goes to the environment, because they have a permit that allows that, and it's not going removed until zero. That's what you need to calculate and consider in the LCA. Important aspects in the inventory are the functional unit, the system boundaries and allocation, and the type of data and the impact assessment methods. I will go through some of this. So functional unit, it's expressing the function of the system and basically what are the reference flow that are used to calculate and quantify the system, and it's also the basis for comparison. As an example, when you look into the famous and often reiterated packaging studies, it's the liter of contained product. So 1 liter of Coca-Cola in a glass bottle versus 3 cans that are, or 2 cans with each half a liter, are the ones that can be compared. This simple example might give you the idea that, is that already enough? No, it's not, because the transport systems for glass bottles and for beverage cans are different, and especially Coca-Cola had glass bottles that were huge and heavy, and back in the days before they switched to PET as packaging material. So here you have of course a bit of a system. You need a bit of a system perspective and need to understand what's around the liter of contained product to really get it right. When you look into paint or wallpaper, it can be an area that's painted for a distinct time. And in transportation, it's often, that's something that we need very often, that we look into person kilometers when it's passenger transport, or ton kilometers, or maybe cubic meter kilometers when it's a good. Always want to. No questions yet? Are you still here? Yeah.
Yes, do
Yes. Yes.
Nice. I'm not sure if it's too fast or too slow. It's try to give you an idea what it's about, so you know next time you want to apply it. And in Swedish it's called beställarkompetens. So if you are the commissioner of an LCA the next time, then you have hopefully very good ideas what is it that you are ordering. And I was still with the system boundaries, or I was still with some packaging examples, and that seems to be a recurring topic in the early stages of LCA, and it's quite nice because it can, so many things can be exemplified with it. So one packaging study, and that was in the 1990s, so that was before the ISO was released, and they have now looked into different types of packaging. And again, one was a reusable packaging that was then cleaned and filled again with the same product, and the other one was something that was a one-time use disposable packaging, which then could go to landfill or incineration. So these are two products that are have some different characteristics, and this can give you a headache, or this needs some attention to get this right. So the question would be here in this type of study, what are the environmental difference and different environmental impacts between alternative waste handling, way of landfilling or incineration, and the next two options I would not call waste handling anymore. That's also a lot of the language has changed during the last 30 years. When you have material recycling, where you take back the materials, or when you have reuse, and in that case you have to clean the packaging material very thoroughly to bring it into the use phase again. And the effort for cleaning it is something that you need to consider. The effort for processing the materials for the recycling is that you have to consider for all the cases where you close the loop to understand what are the benefits compared to just dropping it onto a landfill. That's no longer an option. 1990 it was still accepted, but we now will think that prior incineration and then landfilling the ashes is the way to go in the European Union, at least. So how did they do it? And their idea was, yes, when you incinerate the packaging and if it's made of plastics, for instance, polymer, then you have some benefits because it can be used in district heating, at least in Sweden. That's what is the energy recovery that we all rely on. And so if you incinerate it, then instead of recycling and cleaning it, then that means that when you recycle it and you cannot incinerate it, you need to produce an alternative fuel that you need to feed into the district heating. So incineration has a benefit, and it has a needed and benefit that's in demand. And if you kind of cut this path and say we want to recycle and clean it instead, then you have to find an alternative fuel. So this is a bit of the concept behind system expansion. That's might be a bit too complicated. Hope you did understand this. It's part of the. It's important for the circular economy that when you decide to go for one cycle, you also can no longer feed into another cycle, and so therefore you need to also assess what are the benefits of different parts of different options. So back to our detergents, and this is the result once they did the study for this detergent, and they found out these are the inventory results, and it's quite a long list. And if you look into it, it looks like the detergent one has more emissions in some of the quite a lot of the listed flows. But then when you look at phosphorus, there's more from detergent two. So and aluminium is also more from detergent two, and so and particles and whatnot. You can find it yourself. So it's not so clear when you have this list of flows, which of these two examples is the better one. And this is where the next stage of the life cycle assessment can help you, because then you can do an impact assessment and try to aggregate the flows, first by classifying them and seeing what do they contribute to. And one of the contributions that is the climate impact. And here we have some carbon dioxide and maybe, no, we don't, and methane. So they would both be contributing to climate impact. And that's the first step. And since carbon dioxide and methane don't have the same impact on climate impact, so you can for 1 kilogram of methane has the same impact as roughly 25, depends a bit on the time frame, kilograms of carbon dioxide. So this is the characterization where you kind of refer to the lead unit for different impact categories. Yeah, the impact assessment is the part where you aggregate the data, and the degree of aggregation in LCA can be that you display inventory results. That can be quite overwhelming soon, and I think it was, even from this simplified list, it was clear that this might be a hard ask to assess, or to just give some opinion on which of the detergents is better. Maybe you can do that, but To be safe, it would be good to do this characterization, classification and characterization. And there's even the option to put it all together and do some weighting. So you have the climate impact, you have toxicity impact, you have water scarcity impacts, and then you merge them into a one-dimensional index. And this last one needs a step that's called weighting, and you're not allowed to do that in some types of LCA. So if you want to use your results and communicate with the general public, then weighting is not an option. That's has to be foregone. The basis for weighting can be the economic information. So how expensive is one of the products, the political goals and targets, critical loads, and can be more. For the impact assessment, it's also relevant to understand what's the time horizon and geographical scale, because the characterization factors can be different for that. And it has also have to have some relevance for the application. So when you select impact categories, and then you also want to understand that they are the relevance for the final application that you are targeting. So still right. What we can do is I can go for 5 more minutes, and then we have a 10 minutes break or 15 minutes break, however much you need. Is that okay?
That sounds good. It's very interesting, Jutta. I think that is why we are quiet. We are listening intensely.
and probably writing down a long list of questions. So
yeah.
Mm-hmm.
So
okay.
let's go for a little more, and then we take a break.
Right. Yeah.
That's
then I think that I will need this to come to the end of the method section,
Yeah.
and then we will have a bit more different types of questions afterwards.
Sounds good.
So, very good. Thank you, Nina. And one of the concepts of environmental impacts and having an impact assessment, that you have impacts with a different range. Some of them are global, and some of them are very local and very individual, and they can also last different amounts of time. So one of the impacts that you recognize again is the global warming. So that's climate impact. That's a global impact. So the carbon dioxide that's released to the atmosphere at a random point in the world will contribute to global warming all over the globe. So it has global warming, and it is global warming. And on the other hand, if you have a lake and release some phosphate into it, then this is something that affects the local lake. It doesn't affect the entire world. So this is a bit different. And air, noise, or air. I think air. What's missing here when you it's smell basically, and noise. That's something that can be very local and very close to the point of release. And this is a bit how different impact categories are sorted. And here you can also see a first bit random selection looking nicely. So the trees that are affected by the acid rain that I mentioned when you couldn't hear me maybe, and the lakes that are affected by phosphate. And the toxic substances cause a bit of a problem, because we have toxic substances that have a local impact, that are heavy metals, have an impact close to the source. But we also have now a lot of persistent organic pollutants that are just not degraded in the environment. So it's also we know that the polar bears are affected by chemicals that we use, among others, in textile finishing for the water and oil resistant treatment. And this is also a toxic substance. So this is an effect that can also be seen as global. And that's, of course, we learn more about all of these parts as we do more and more studies. So starting from the inventory profile, where you just list the flows and try to make this up, then this is how you would do it. You go for the impact categories via this classification and characterization step. And then the final step would be evaluation. As I said, it would not be you will not do it when you do a study where you want to publish the results and do it as a comparative assessment, and that's intended for publication. But for internal usage, that might be a good idea, that you say what's the impact in one number, and that can be points, or it can be the environmental load units, or there's also another method that's suggested by Dutch research, and it's called recipe. So now you have done all this and collected data and thought very thoroughly what to include, where to do the allocation, where to set the system boundaries. And since you have done so many decisions along the way, you want to find out, are they really sound and are they really valid? And what happens if we change some of the assumptions? So this is the part of the interpretation, where you look into data sources and allocation. I skipped that a bit because it's a bit complicated, but we can you can contact me about that, and I can probably give you some examples on that. What are the models that I've used in the impact assessment? And then you start checking, is it consistent? Is the data quality that I've used appropriate? Have I taken all flows into account that are relevant, or have I decided to cut off some parts? What is the uncertainty and what is the completeness? So this is the interpretation part. It's at least part of it is of course communicating the results, but a lot of interpretation is also related to understanding how robust are the results. So I think I have one more. Yeah, and one part of the interpretation can also be in hotspot analysis, and there you try to find out what are the relevant parts of it. So hotspots, are they relevant for internal decision making at company level? For examples, we have some designers here. You want to find out which are the relevant elementary flows, which are the relevant processes, and which is the relevant life cycle stage that I want to address and consider in the next design. And for the more external communication, and also for maybe policymakers, it's also relevant to understand what are relevant impact categories. And I think I will check. Now you see the live. Yeah. I have one extra slide. So test the results to see how robust they are. Do some scenario analysis. That's a part of an important part of the LCA once you're done with all the data collection, and then you have probably need to do the iterative thing and add some data. So now I think yes. I think I know that I've gone through all the methods from that are related to LCAs, and at least as far as we could do it in this 1 hour. There's much more to say, of course. And now I have some LCA findings that are especially related to textiles, and the examples are mostly taken from the Future Fashion project. So it's not entirely focused on closing the loop on collection and recycling, simply because there are not so many studies already available that tackle that. I think we have started working on this. Lisa Schwartz can probably confirm that yes, there's not so much done in the area of recycling. What's the benefit for recycling? And we have to make do with the data from life cycle assessment that we have found, and probably shape the research and the studies that we need to do in the near future to get better insights here. And one of the results from, or the vision for 2030 from the future fashion project is that you apply the best technique that you can think of, or maybe also the best available technique as it's defined in the document that's currently still under review, but will be published soon, that describes which technologies and which techniques and which production process are considered as best in textile industry and textile finishing industry. And if you can apply them in general for all producers, then you will have a smaller footprint, the small footprint on the left, on the right, sorry, on the right. As it stands at the moment, that we know that many companies use a lot of water and maybe use too much water and more than they need, and also use chemicals that we would not recommend anymore, that have been established a long time ago before we knew about toxic implications. And they also use a lot more energy than they would do if they work more efficiently. And then there's also a bit more consumption. That's what we know, that consumers also like to have new items. That's maybe something that you as designers don't want to, if you're a designer, don't want to reduce the amounts of pieces that people are going through per year, but that could also be contribution. So this would be a way for the Swedish textile and fashion consumption to reduce the footprint in the next few years, and it has to be more combined action. And what you don't see here is recycling or reuse or anything like that. But of course, that would also be an approach to contribute to best techniques. So instead of starting from raw materials that have to be dug from the soil or dug from the earth or taken from the soil, combining that with a closed loop could be also a way to apply best techniques. We'll see about that. Trying to find my little arrow again. Go to the next slide. So the 6 garments, or 6, I think it's 6 garments that were considered as basic wardrobe for the Swedish fashion industry. They have been analyzed regarding their climate impacts and water scarcity impacts from cradle to grave, and what are the contributions from different parts of the life cycle. And what is an interesting find is that for the climate impact, it's quite balanced. So fiber production contributes quite a lot. I think it's one of the bigger contributions, but also the wet treatment stage, you also contribute a lot. And then the confectioning stage and the fabric production and yarn production in that order. So here you can see that when you want to reduce the climate impact as a part of the environmental impacts of your of the fashion or of textiles, then it's a good idea to start with these types of the parts of the life cycle. It's sort of a hotspot where you have a higher contribution. It's not the most relevant part if you start improving and working with the use phase laundry, because then you will not get so much out of it. That's for the climate impact. And what is interesting is that when you look at the water scarcity impact, then you identify immediately that there's a big contribution in the fiber production from cotton. That's almost 90%, or it's 87.4% of all of it. And that's something that has been discovered in recent years, or for quite a while now, that the upstream and fiber production for cotton, it's a very popular fiber, and I admit that I probably wear mostly cotton on a regular basis, because it feels nice on the skin, and it's has so many positive options for the user. So we really like our cotton, And it's also one of the fibers that has a lot of impacts especially for the water scarcity. It's cotton is a funny fiber, or is a funny plant, because it likes to grow in areas that don't have a lot of water. It's not a desert, but it's on its way there. It's called steppe, I think, in English, Steppe in German, if you ever come across that. So it's semi-arid, and it's arid, and it's needs a lot of irrigation. And this could be, even though this is not about recycling per se, it could be a starting point to find out what are the benefits of recycling. And one of the benefits of recycling cotton would obviously be that you reduce the impact on water scarcity. And that could be a very good incentive to see that you don't throw away and don't incinerate cotton. There are more impact categories that are relevant, and that's the human toxicity part, where you again see that the fiber production has a high impact in several of the for several of the garments, for t-shirt and jeans, and also the hospital uniform, that all contain a lot of cotton, coincidentally. And it has, for the cancer cases, it's not so big there. It's quite nice that you don't have it as the largest contributor for all impact categories, but still, when it comes to the non-cancer cases and human toxicity, the fiber production and cotton fiber production is a high factor. So from a scientific facts, basically, if you start and try to find is there one material that I should use, preferably, it's not so easy to say. And the LCA practitioners and academic LCA people often have, as a result, if they have get such a question, and they say depends. And in this case, it really depends on the suppliers and the type of supply chain, and which technology is implemented in the supply chain. For cotton, we know that instead of the conventional type of growing, cultivation, and harvesting, you can actually get some good organic cotton, which then doesn't use water from wells and groundwater, but tries to use as much of the rainwater as possible instead. So you can reduce the water scarcity footprint of cotton by using a different type of growing and cultivation. So this is obviously one of the strategies that you can go for. There's one thing more. Chat. Somebody's in the chat. Can you say what you want to say? Because I cannot.
Yeah, sure. I just wonder, how can we make sure or impact our suppliers that we very much rely on when it comes to these questions, to work with the best dyeing houses, for example, from a sustainable perspective?
Yeah, that's a good question. As working with the supply chain it's probably easier said than done. But if you have a stable supply chain, that you come back to the same suppliers time and again, and then you can also probably put some requests on them, and you can of course select suppliers where you know that they use innovative dyeing techniques, so spin dyeing instead of the traditional wet dyeing, and all these types of activities are possible. When it comes to organic cotton and other organic supply chains, you can also rely on, or the first step is to check whether the suppliers have a certificate, and have their certificates, for like the GIS certificate for recycled materials. where they the suppliers actually have to open the factory gates and have to go through an audit that confirms that they not just have a hang tag that says they are using recycled material, but they are really do that. So that could be that's at the moment what can be done, relying on certificates, and increasing also doing your own audits if that's an option. And yeah, probably checking the future fashion results. There's one of the publications is on working with the supply chain, so I would at the moment refer to that. Because maybe as a conclusion is also, of course, it's relevant that you what you find out from suppliers, and that this is that you can trust them, and the textile industry, textile and fashion industry is like many others, often there are challenges from customers who say that this is greenwashing, and you cannot really say that you do that, that you do a special process. You have to provide evidence, and you have to confirm that. So this will be probably a bit more established in the future. And doing LCAs is always a good way to find out which are what's the contribution from suppliers. So, but I understand that you cannot do LCAs for each and every garment that you're working with. That's probably also a big ask. We can maybe take the next and then see how far we get, and open the discussion again. So this the water scarcity is one of the topics that have been discovered a bit later compared to climate change, but it's a very relevant question, and it's also one environmental disaster that can actually be seen from the satellites that are flying around. So NASA can take pictures, and they have taken pictures a long time over even when it started in the 1960s. I think was the Aral Sea was a really nice lake and the biggest on the planet, and now there's not much left. And the sea's depth increased from 30 meters to 42 meters. Yes, so it's not getting worse than it's, but it's not a good situation. And this is not only the water is lacking, but it's also that the soil is now very much affected. Has to do with the cotton cultivation and the way cotton is cultivated. It's cotton actually is a plant that would grow several years. So if you want to have a harvest at a specific point in time to make the harvesting more efficient, you use specific pesticides that will make the plant drop the leaves, defoliants, and that also means that the area where cotton is cultivated is not only deserted, so the water is lacking at some point, or the water is lacking elsewhere because it's directed to the cotton fields, and it's also has a high load of contaminants that can be heavy metals, it can be organic pollutants that are everywhere there. So there are pictures or films, short films from the Aral Sea, where you see that it's not only windy, but it's also a lot of dust, and this dust is probably quite toxic and contains a lot of stuff that you don't want to have. So this is what we know about cotton, and this is also what consumers and potential business partners know about cotton, and therefore this seems to be something that's very timely to address this type of questions. And what you can do about cotton is twofold, or there are two general approaches, and probably have to combine that in a good way. So the very general options that you have is that you replace cotton with other types of fibers, and that can be forest-based fibers such as cellulosic fibers. And the other one is that you replace the cotton with chemical recycled cotton. That's an approach. I think we work with both, and it's not so well established yet. So it's still a part where a lot of research is going. But what we see from a comparison of the carbon footprint, the climate impact, is that there's not much happening. So the organic or the conventional cotton, virgin cotton, and the forest-based materials, cellulosic fibers, and the chemical recycling cottons, they end up pretty much in the same range. So if you do the interpretation and do a test of robustness, you will find out that this is not really switching to Tencel or lyocell is not an option to decrease the climate impact of the garments. But then you look at the other impact that has been addressed here, and there it's so clear that yes, these are both very good ideas. So switching to Tencel or let's say viscose cellulosic fibers, or switching to chemical recycling cottons reduces immensely the water footprint, the water use and water scarcity footprint of cotton, at least according to the data that we have. So that's always to take with a grain of salt, because the data quality in the databases, I strongly suggest that it has to be reviewed. I'm not so sure about all of the data that I found in the database when I checked. Another idea is also to at least reduce compared to the base case, not to the same extent, but at least to some extent, is to go for organic cultivation and to not use any mineral fertilizers and synthetic pesticides anymore. But that's of course also a given, and it has also impacts on the recycling process if you have cleaner materials that you put into the system. A little bit more on the cotton life cycle, where you can reduce the impacts is that you check the core process and identify if there's improvement potential for the process efficiency in the pre-treatment, spinning, fabric forming, finishing. This needs to be considered where it's affected, and that means also if you move from a primary or virgin cotton to a recycled cotton, and then cannot use it as a drop in as you wish. But you have to treat it more carefully, or you have more losses in pre-treatment, you have more losses in spinning because it's breaking more often. Then this is an effect of recycled cotton in the life cycle that needs to be considered, and need to be transparent about that, and say if really 1 kilogram of recycled cotton can replace 1 kilogram of virgin cotton, or maybe you need a bit 1.05 kilograms to really come to the same function. Therefore, an LCA in this case that really is very transparent can really be helpful. I think we're going to work on this in the upcoming months and years very thoroughly to really get the quantitative data here, because there are so many people who are interested in this. And then there's also the downstream, the post-consumer parts, where we look into textile processing and treatment. That includes the collection. How is this organized, and what's the effort to do this? How is this done? Sorting, after that, the direction to reuse where this is possible, or recycling and material recycling, chemical recycling, mechanical recycling, whatever are the options. And the effort for chemical recycling, if you do that, includes then also production and use of chemicals. So everything that's needed to make the recycling process happen, that has to be considered. And then you can make a comparison to the primary production process from virgin material. So the recycling, all the cleaning, processing efforts need to be balanced with the reduced upstream efforts to really come to a conclusion. What's the benefit of recycling, and quantify that? And that's probably what you thought you hear more about today. But that's where I can say that we're really working on this and trying to get more data on that, because as of yet, it's not so well covered. But we have the tools and the means, and we know how to do it. So maybe just a bit of work to do.
Yes, because you could say that there are so many processes under development and they are different in
Exactly.
scale, which makes it very difficult to exactly know what the data would be if you would have these processes in a larger scale, so that you can sort of be sure that the processes would also be optimized. Since it also takes into account, as Jutta mentioned, the collection. Where is the collection done? And where would any kind of facility be placed? So there's also the matter of transport between them, so that the entire system would be optimized and how that would affect the life cycle assessments.
Yeah, a lot of work to do.
Yes.
I go to the next one. So no, the next one, not the previous one. So we talk also about other types of environmental impacts, and some of them are more emerging topics, where we not really know what will be the implications in the end. And one of them is the shedding of microplastics, which can also come from garments, and where also the recycling is suspected to be a contributor. So if we recycle garments containing plastics or synthetic fibers, then the shedding of microplastics to the environment from washing machine, also from wearing, might be increasing. We don't really know that yet, and there's also not really an environmental indicator or impact categories that's addressing microplastics in water. So what Sander has or what some researchers here, Spee et al., they didn't find any increase in the microplastic concentration over the last 3 decades, despite an increased production of plastic. So the plastic concentration in water or in fish seems to be quite stable, and I think we need to learn more about the plastics. But of course, on the other hand, you can also say, if we release it and then it's all out there, then it will be a very tough ask to get it back and to recover it and do some remediation technologies. So this is also one of the environmental parts that's emerging, where we really need to have a closer look, but we don't fully know the effects yet. And recycling, of course, maybe contribute to an increase in the future. Then the big topic that's mentioned in a lot of contexts is, of course, the climate change effect. And there you could see that switch from cotton to other types of fibers and to recycling cotton didn't really contribute that much. But climate impact is a big item in currently in society. So changing or combining several aspects to reduce the climate impact is what we go for. So change in customer transport behavior, reducing the cutting rates from 20 to 10%, 10% longer life length, and reducing the heat from bio-based, or increasing the heat from bio-based sources instead of fossil sources, using synthetic fibers that are dope dyed, and using electricity that's also coming from renewables, combining all that can actually reduce the climate impact reduction. Most of these aspects are not fully related to recycling, I admit that, but one is because recycling can obviously also increase the life length of a garment, and it doesn't have to be just the one user, but you can also think about that by designing or producing a garment that is durable and that can be used by several users in a sequence, will also reduce the climate impact by this contribution, that you have an increased life length. So this is how we would frame it in an LCA. Yeah, I think these are, I can go through that a bit quicker, because these are several aspects related to spin dyeing and replacement of conventional cotton. That has also, when you look beyond the climate impact, then this will also lead to a reduced emission of toxic chemicals to the environment, and that's obviously also a very good thing. And if you remember, what is measured is improved, and that's a bit of the risk when everybody's focusing so much on climate, that we don't see what's happening in other parts of the life cycle analysis or life cycle assessment. Sorry, now I said it. Because we have the opportunities to look broader and to find out what's going on in related to climate, but also to other parts of or other impacts related to production. Yeah. Here comes a bit more. So here are the effects of reducing the toxicity, and it's different for different parts of. There you go. It's the cotton dope dyeing instead of regular dyeing has reduced impact on the non-cancer, but it's much more impressive when you look at the cancer impacts, and then it's a bit different for cotton replacement, and for dope dye and cotton replacement combined, it's at least 50%, but it can also be a bit more for the cancer impacts. And this is a bit of what happens in impact categories that are maybe a bit more complicated, because here you maybe would expect it's human toxicity, and this is also human toxicity, but one is related to causing different diseases, and this one is related to causing cancer, and the results are not absolutely the same. This is what we observe, and this is where we also think that getting more data and getting better data and getting better impact assessment models will help, because it leaves a lot need for explanation, of course. And we have the same also for the toxicity aspect that are not related to humans, but to the ecotoxicity, also the environment, little fish and fresh water in this case it is. And here you can also see that that cotton replacement doesn't really contribute a lot, but having this dope dye is here the more effective and higher contributor to reduce the environmental impacts. So as on a higher level, now I've shown you a lot of details and a lot of the complicated details that maybe that really need to get input from data, and to which the life cycle assessment and all the studies that are ongoing can contribute. And if you want to combine it all in a checklist, what can be done to reduce the environmental impacts of a garment, then the Mr. Future Fashion project ended up with this checklist, where they suggested to increase the lifespan, and that results in an increased number of uses. And I think that you can say that this is mostly very closely related to closing the loop and recycling. So here you have the impacts per number of uses is affected for climate impact, water and chemicals. So but it's written in small. So that means they didn't really find a very high impact when you do that. But having a better production technology and using secondary materials in production, here you probably can do a bit more, and you have a big impact: less energy, less water use, and less wastewater treatment if you don't use the worst chemicals that are you can think of. Then you have the better energy sources, where it's quite obvious that this will have an impact on the climate mostly, but not affect the water and not so much affect the chemicals. Better chemicals selection, on the other hand, again affects all three impacts that are listed here, or general impacts. Choosing better materials will have can have our finding of the future fashion project was that this really can reduce or contribute to less water use with a large impact, not so much to chemicals. Minimizing microfiber shedding. We expect that this will have an impact on polluted water and also have an impact on toxicity, which will be reduced. But microfiber is really an emerging topic, and even the experts are not so sure how to assess the effects of microfibers in the environment. Optimizing transport and packaging obviously also has the listed impacts and effects on climate and chemicals impacts mostly. So this could be a checklist whenever you start designing a garment. Which are the actions that you want to consider, and what are the effects that will be harvested when you manage to do so. And coming back to the optimizing the lifespan part, and I think this is very much also related to the reuse of garments, but it can also be related to recycling garments and recycling parts of garments in another context. Is when you have an average garment and that you are supposed to use for 30 times. Then the climate impact per use is high. It's above 14 kilogram. When you have an average garment which is supposed to and use it for 60 times instead, then you can immediately reduce the climate impact per application or per use. So so this is some of the parts that has to be considered, and it's divided evenly within all parts of the life cycle. So this affects the disposal, laundry, consumer transport, distribution, fiber to garment, and fiber production. All of them are affected. So having a garment that can last longer and can be used more intensively, and maybe not by one user, but it's suitable also to enter a reuse cycle and a recycled cycle and be used more efficiently, the material that can really help. Yes, so this is calculated for a hypothetical garment of 0.5 kilogram, and it's assumed that you can double the life length without running into problems. And maybe you don't want to use it after 30 times because you're tired and bored, but then give it to somebody else who can use it. That's obviously also a very good idea. There are some actions that can be taken. Analyze which factors decide the lifespan. How many times does the average consumer use the garment? So knowing more about the clients and the consumers is an important part. And analyzing causes of returns. Where is garment returned? So what's the cause? and that's the same for the brands and distributors for the unused garments, and also the claims that are made after use when it's not possible, according to a consumer, to use a garment any longer. And here are some improvement actions. Define who the intended user is and how many times the garment is expected to be used, include in the design brief. And this is maybe also one of the parts where the fast fashion people have a completely different approach, because they say, well, it's fashion, so it's not used a lot of times anyway. So instead of making it more durable, we accept that the user doesn't want it anymore, and try to reach that goal with a limited minimum effort. But that's obviously one approach, but making the design more timeless or classic in collaboration with dedicated customers can also be one of the approaches. Guarantee the life length of your garments. I don't know if I will put that away. Oh, sorry. Now, can you still see my screen?
Yes, we can see it.
Yes.
But I can't see it.
Oh, okay.
I clicked on something. So here, now I'm also back. And then working on the constructions of the garments to reduce the seam slippage, and use fibers with good durability, use dye stuff with a good durability, select back the options for parts that are likely to be worn out first, print with lower technical performance than the rest of the garment, and use on working on zippers and reflecting tapes. Children trousers, where the knees will just give way sooner than the rest of the trousers, and for shoes, soon soles instead of glued will improve the technical lifespan. So this is sorry, this is a list. I will just mute myself for a second. This is a list that you can working on when you increase the lifespan, but these are also all factors that might be relevant when you think about designing the recycling stage and working on that. And Lisa has mentioned that the collection can be quite, or is already quite a challenge, because it's not organized in a very specific way, and it can be very different from town to town even. So what you do in, for instance, here in Göteborg and in Mölndal might have very different approaches in local communities. Yeah. Then we work on a better production technology, so improving the efficiency, reduce the cutting rates, reduce the rework in the production facilities, and here also the usage of recycled materials and secondary materials instead of primary materials can be a contribution. That's not so considered so much as of yet. It was not so much in focus in the future fashion project. They talked about it, but they didn't have it as so much at the center of their research. Using better energy sources, using better chemicals, and selecting, also reducing the amount of chemicals that are used. And here we have the famous RLC again. I think it's quite obvious that this is a big ask and a big task for all of us. Can you use different types of fibers? Can you use polyester instead of cotton? And also, can you use recycled cotton instead of virgin cotton? Avoid unnecessary materials, standardize trims, and increase control for high-risk materials. You will get the slides so we can have a look afterwards. Also, avoiding the microplastics, if that's one of the goals that you include. And optimize transport and packaging. That looks horrible, doesn't it? With all the emissions coming from the planes, reducing the air freight, reducing the anti-mold agents and all the chemicals that are used under transport, and optimize the packaging materials. So I'm afraid this was not so as you could see, and or as you now find out, that it's not so completely implemented looking into recycling, because this is really one of the topics that's still emerging. But I can see a lot of using recycling policies and reusing policies also to contribute to coming to a more sustainable fashion. So I think that's mostly it. Yeah. One of the parts, and I maybe to close the loop here also, and go back to how Jonas also ended, there are some fact-based communication, and there are standards available, and there's the HIC index available, also the environmental footprint, environmental product declaration, and the product environmental footprint that you can use to investigate what are the environmental impacts based on a life cycle perspective, and then avoid the greenwashing and the accusations of greenwashing. That's probably an important part also. I think I'm done, and I should be